Says the manager of a grocery store has taken a random sample of 289 customers. That's N. The average length of time it took these 288 customers to check out was 2 minutes. So that's some sort of X bar. It is noted the standard deviation of the population of checkout times is 1 minute. That's very important here. So that's sigma. The standard error is 0.05888. So we should know how to calculate that. The standard error is sigma divided by the square root of n. So if it truly is 1 and the square root of 1 of 289, that's 17. We should just check real quick. That is in fact 0.0588. That does look correct here. Yeah, that is correct. So that's the 0.0588. So they're being kind of kind there. Find the margin of error with a 0.95 probability. So your margin of error is the z alpha divided by 2 times sigma divided by the square root of n. You actually have the sigma square root of n. That is the 0.0588. You need the alpha level to do this. So that comes from C. C is 0.95. Alpha is 1 minus C. You do want alpha divided by 2, so you divide it by 2. 1 minus 0.95 divided by 2 is 0.025, like that. So that's where you go to your table, go to your calculator. We did this yesterday. That produces a z value of 1.96 times 0.0588. Do you have a calculator available today?
No, I'm trying to pull one up.
Okay. All right, so if you grab your calculator there, you should find that this is 0.115.
So how did you pull up the one that you used, like to show me?
The virtual one?
Because when I type in the virtual one, I just get the Mathway calculator.
I mean, I can find it. I mean, that one I use just because students want to see how to use the TI-83. Let me see if I can even find it here. I don't recommend using it unless you have to use it.
Yeah.
Basically, I'm saying like use something else. Like either get your calculator or because it's really just an emulator. I don't know. I downloaded it somewhere some million years ago.
It's all right. I'll just use this one.
Yeah. Okay. In terms of just doing calculations, I'll drop this one in the chat. This is a nice one to use just to do, some of the simple multiplications. Okay, let's move on to question number 2.
Yep.
We'll grab that there. There it is. All right, here it is. Random sample of 25 employees. That's N. At a local company has been taken. 95% confidence interval again. For the mean systolic blood pressure for all employees of the company is 122 to 138. Which of the following statements is true? If the sampling. Okay, this is just a pure sort of definition. I believe this third one is correct. It may, yeah. You can also check this one online later, but do you want me to just do the numerical ones? I'm sorry, I forgot to ask.
Yeah, that's fine.
Okay, so I will skip to number 4 now.
Number 2 is right. Yeah. So is number
Good. Oh, good. All right, so a sample of 196 cans. So you always want to identify the variables. N is 196. Average weight, X bar, 128. Standard deviation of the population, that's sigma, is 1.7. Construct a 68.26% confidence interval. That's weird, but that's what they want for this first one here. All right. So to do that, you're going to go to your calculator there. I guess I have to reasonably ask here is do you have a calculator before the exam that you're gonna be able to get, or are you
Yeah, I
like,
do.
what's going on with your calculator situation?
My roommates both have one, so I usually use one of theirs.
Okay. All right. So these sessions are going to be way better if you're able to use a calculator, because I already know how to do these, and frankly, I don't care if if I get these right or wrong. I mean, it's for you. So, is there any way you can get one for today, or is that just out of the question?
I tried asking my roommate, but I think he's sleeping and his
Okay.
door's locked.
All right. So to do this, you're going to use a Z interval,
Hmm.
and you're going to go to stats because you don't have the data. They didn't give you a data set. They gave you the output. Your sigma is 1.7.
Okay.
And your X bar is 128. And your sample size is 196. All right, now your C level, this is the first one that's really odd. So notice it's a decimal 0.95. If you can see the blink
Mhm.
behind the blinking cursor.
Yeah.
If you don't like calculating it, or you're like wondering, like, I don't want to make a mistake, I believe you can do like just divide by 100 here. And you can see that when you hit down like I did, it does calculate it there. So if you're not sure how to do it, divide by 100 percentage. Let me take a snip of this so you can have it for reference. And
Mhm.
then let's go to calculate here. All right. Okay. So 127.88 to 128.12. Go back to the other screen. All right. And that is the first one there, round to 2 decimal places. So it's already done that for you. All right. So it's this part B here says to construct a 97% confidence interval. So the only change is going to be to the C level right there. You're going to change that to 0.97. All right. And then you redo the calculation. So it's real nice. You don't have to re-enter all the values. You just change this one. I'll do that now here. 0.97. All right. Let me snip that in case you want to look at that later. All right. Okay. All right. 127.74, 128.26. And one thing you should notice here is that as C increases, as the confidence interval increases, the width also increases. So the number on the left here is lower than this one. The number on the right is bigger than this one. And actually, that's what it asks in part C there. It says, I didn't even notice that. It says, why are they different? It's because the confidence interval has changed. That's the only thing that changed. So why are they different here? So as the confidence interval increases, narrower, nope, wider, yes. So probably that one there. So you got to be able to go to your calculator and do the Z interval. I think we were doing that yesterday for a couple of questions.
Yeah, I got those. Thank
Okay,
you.
great. All right, number 5, part A is some sort of assumptions. We'll skip past that. We'll go right to the numerical stuff here. All right, B and C. Find the standard error of the means. Let's go back. A random sample of 121, so that's N, sample is N. Average daily balance, that's X bar. The standard deviation of the population, that's sigma, is 77 there. All right, so the standard error of the mean, sigma is sigma divided by the square root of N. So it's your your value is 77 divided by the square root of 121. All right. So if you got that, you say you got a calculator. Why don't you go ahead and calculate that for us, please?
Would it be 77 over 11?
Yeah. Notice it doesn't say it around, so we know that there's some assumption that this must be a nice value. The point estimate of the population mean, this might have been a question from your exam there, practice exam. It is X bar. This is always X bar 265. All right, next two questions here. Construct an 80% confidence interval, then a 95% confidence interval. So to do that, we're going to go back to the other screen and do the calculations there.
Okay.
So if you see my screen there, there it is.
Yep.
So we're going back to Z interval, stat test, Z interval. All right, so we need the sigma. So sigma, I'm just scrolling up on my screen. Sigma was 77. X bar was given us 265. N sample size 121. And C level is, in this first one, it's asking for 80%, so that's 0.80. Again, if you're ever just like, I don't want to take a chance here, you can just divide it by 100. It will give you the correct C level. All right, so there is the first one. It says round your answer to the nearest cent. So that's 2 decimal places. Let me snip this one in. In case you want to look at that later. So 256.03 is the first box. I'm writing that in. 273.97 is the second box. We go back to the calculator for the same calculation. And they just want you to see that it gets wider. So the only change here is that we're now doing a 95% confidence interval. All right, and you can see the results there. So the first box, 251.28, and then 278.72. Any questions on that?
Yeah, I just can't see the screen.
Okay, I mean, any questions on how to do the calculation in the calculator?
Oh, no, it's okay.
Okay.
Yeah.
Let me know when we can move on to the next question here.
1 second, sorry. All right, you can.
All right, so question 7, 6 is not a numerical question. So 7 says you may need to use appropriate technology with degrees of freedom to answer this question. So it says, what is the t-value for 95% confidence interval estimate with 94 degrees of freedom? So we talked yesterday, and I've got another student, I think they're in the exact same class as you, and they did send me the sheet you're going to get on the exam. It does have a t distribution on it. So let me just snip that in here so you can see what that looks like. Looks like it's on page 5 here. So the way to use this is, it looks a lot like a normal curve, really does. There's this thing on the left called degrees of freedom, which it's a shape parameter. It changed the shape of this thing. I mean, I don't really care. You don't really care, but that's what it does. It makes this thing thinner, wider, things like that. In your problem, they're giving you the degrees of freedom. Degrees of freedom is always the sample size -1 for a t distribution. You might need to know that for your test tomorrow or
Mhm.
Thursday, whenever it is. So you notice the degrees of freedom start here at 1, 2. They actually go all the way down to, in your case, they go all the way down to, well, quite a bit. So go down to 100 here. So let me grab up to 94 here. All right. So degrees of freedom. So you identify your row. In this case, it's the 94 degrees of freedom. It's this last row here. And you can see there's all these different columns. Like, all right, right tail probability. What does that really mean? It means the area in the right tail.
Mhm.
The area in the right tail. So in your problem, we want a 95% confidence interval. So that's two-tailed though. That's like saying there's 95% in the middle. So how much is in either tail? So we've done that a couple of times here. Alpha is 1 minus C. So alpha divided by 2, which is in the tail, is 1 minus C divided by 2. 1 minus 0.95 divided by 2, 0.025. So you're looking for the 0.025 column, which is this one here.
Yep.
So that's the value you want. It's very easy to grab the wrong value. Very easy. I mean, I wouldn't be surprised if both values are on here. Yeah, they are. So this is the rounded answer there. This is something you will have to do either on this test or an upcoming one. Any questions on how to use the t-table and
It
tail?
looks pretty simple.
Okay. All right, let's look at new question here. All right. All right, you may need to use technology. Okay, the following random sample from a population whose values were normally distributed was collected. What is the 80% confidence interval for mu? Okay, so the first time we've seen a table of values. So the best way to do it is with the calculator, believe it or not. So I'm going to go over to the calculator and we're going to enter the data into a list. Okay, so that's under stat edit. We want to edit a list. Now, if you've already got some data in your list, you want to go up to the top, hit the clear button, hit enter, and it'll clear out anything that's in your list. It's not like a phone where you've got, modern features. You don't have that here. So we're going to enter the data values 11, 13, 17, and 15. Always double check that you've got the data values entered correctly, because you will find that most of the mistakes are from just missing a number here. All right, so let me just snip this into the other screen so you can see how that was done. Now from here, I always quit the list. I don't try to jump to another screen. I just quit out, kind of like going to the home screen. Now here's what we want to do. We want to do a test on the list. The problem asked for an 80% confidence interval. So this time it's a t interval. Now, one of the reasons it's a t interval is because of the small sample size. Yeah, there's only 4 samples, but more generally, it's because the standard deviation isn't known, which is implied by the small sample size. Although the question should do a better job of saying that, unfortunately, it doesn't. So this time, we've not done this before. You're going to choose data. So you hit enter. So notice it says there list L1. That means it wants to know where is your data, and you're telling it that your data is in L1. That's what the second thing means. Frequency, you almost never change. And then the C level you do change because we want an 80%. Okay. And then you will we'll calculate this. Let me grab the snip here. All right. So that's there. Let's hit enter now. Chugging along here. Come on. All right, there we go. So there's your t interval. And hopefully that matches up to something in the answer space. It does. Jump back to the other screen to look at that there.
Yeah.
So while everything I did was very easy, the question is, will you be able to do that on the exam? And there's nothing difficult about any of the things I just did. It's just, do you
It's
know the
just entering
sequence?
everything
Yes.
correctly.
And making sure there's no errors and all that's like, there's nothing complicated about this. Okay. But
Yeah.
you got to know which test to use. You got to know why. And that's something I can help you with. I'm trying to say it's a T because it's a small sample size. It doesn't
I mean,
explicitly say
we've
that.
done other problems that are pretty similar to the
Yes.
way you enter everything in too. So
Yes. Yes. All right, let's go to question 9. All right, question 9. All right, you blah, blah, blah. Okay, random sample of 49 SAT scores shows, so that's N, an average of 1400. That's X bar with a standard deviation S of 230. Degrees of freedom is 48. Find the margin of error at 95% confidence. Okay. So that equation sheet does have a confidence interval calculation, and it's on the right side of page 1. That does this. I mean, I guess I could download this here. I'll drop it in the chat here. Take a look at that. I mean, that should look pretty familiar to you. That's what I'm pulling from. I'm pretty sure it's the same class, but only you will know for sure. But it's this second formula on the right that we're going to use. So you can either use the formula, or you can kind of do it with the calculator where you make a T interval, but then you have to find the width of it and divide by 2. So I would recommend we just use this part on the right. Let me do it differently here. This part in red is the margin of error. So that means you got to find your T alpha divided by 2, which means you got to do like what we did in the previous problem. But at least you have S, at least you have this, you have N here. So on the 5th page of that sheet that I sent you, the degrees of freedom here, 48. So let me snip that in. Normally you have to calculate degrees of freedom, but they're giving it to you here. So you're looking at these numbers right here. And then at the top, which, let's see if I can snip that in. Yeah, I think I can get that work there. Let's get a little bigger here. Yeah, that should be good. Okay. So you're looking at, and it depends on the problem here, you're looking at 95% confidence. So that's in the middle. 0.95 is in the middle. So how much is in either tail? 0.025. So that's why you go to the 0.025 column, and then you want that value there, 2.0106. So that's your T. That's your T alpha over 2. Your S is 230. Square root of 49 there.
You want me to get that?
Sure, that would be good. Sometimes you can kind of estimate which one it is, but we got a calculator, so we'll just do that.
(230/7).
And what about the 2.0106? Can you multiply that all out for us, please?
Oh yeah. 66.062. So
All right, so close enough. Notice
well,
it's really close, maybe off by the last decimal place, but pretty close. All right, any questions on that before we move to 10?
No, I think that's all.
Okay. All right, 10 here. Random sample of 64 SAT scores. That's N. Average of, that's X bar. Standard deviation of 200. Find the t-value. So we're just looking for the t-value this time. We're not actually looking for the margin of error for the 95% confidence interval. So again, that's alpha over 2 is 0.025. Degrees of freedom in this problem is n minus 1. That's 64 minus 1. So we're going back to that same chart. But now we want to go down to 63. So grab that here. There's that. Let's grab the header. It's so much easier when it's printed out in front of you, but this is what we got to work with today. So we got 63 degrees of freedom. And it's easy to grab the wrong value too. The highlighters recommended here, 63 degrees of freedom. And then we want the 0.025. So we want the 1.9983, just like that. Do you feel comfortable using this table?
Yeah.
You got to go down, grab that, match it up with one of these numbers at the top. Is it clear why it's 0.025 from 95%?
Yeah, because you follow the 63 over to.
Yeah, but why, like, is it clear why we're going from 95% to 0.025?
I think I lost you there.
Okay, so the C value is 0.95. Alpha is 1 minus C, so that's 1 minus 0.95 or 0.05. Because it's a confidence interval, it's two-tailed. Two-tailed means you divide your alpha by 2.
Okay.
So you divide everything by 2. So alpha over 2 is 0.025. Because as soon as you're going to have like a 90% confidence interval or maybe a 99% confidence interval, and you've got to be able to go back and forth between them.
All right.
All right. So any questions on that before we move to next problem here?
I think that's all.
Okay, great. All right, so number 12, skipping 11, it's a non-numerical problem. All right, you may need to use the appropriate technology. Okay, so local university exam for candidates, a certain thing, 5 examinations are selected at random. Here are the scores. So you want to calculate the mean and the standard deviation. Your calculator, again, will do this for you. So I'm going to jump to the calculator.
And then put it all in L1.
Yeah, and this time I got junk in there, so I'm going to clear out. So go up to L1, you hit clear, you hit enter, and it's gone. If you want to keep the list, you can. I could jump over to L2, but most students just work out of L1. Probably for simplicity, I would recommend that. 85, 88, 58, and 72. Just double check. 77, 85, 58, 72. Sometimes you can actually go backwards. That's a good way to double check. Go in reverse, see if it's right. All right, so quit out of this. To determine the mean and the standard deviation, you go to stat calc. This is a little bit different. Stat calc, I'm writing this down. And you want to choose one variable, stats. Now yours might be like mine where you have to give it a list. And I'm going to choose L1 there. Let me grab a snip of this. All right, let's go back to the other screen. Go. Okay, so the mean is X bar, that's 76. Okay, standard deviation is this SX right here. 5 decimal places. Okay, so that's going to be 11.895 3.8. Any questions on that?
Sorry, 1 second. So you went. The calculations was a little different on that one then, right?
Yeah,
You
stat,
put in
calc,
stat,
one variable stats.
and then the mean is the 11,
The mean is X bar,
76.
76, yeah.
Okay.
Let me know when we can do parts B and
Yeah, that's
C.
fine.
Okay.
You can go.
All right, so part C here, develop a 95% confidence interval for the mean of the population. So we're going to go back to the calculator. We're going to do D first, and then I'm sorry, C first, and we'll come back to B. So I'm going to go back to the calculator there. And this is a T interval. The reason it's a T interval is you don't know the standard deviation. You have a small sample size there. So you go back to stat, test, T interval. And this time you're gonna use your data. The C level is 0.95. So let me go ahead and grab a snip of this. And now I'll hit calculate.
So for that one, you do data then, right?
Yes, because you have that list of information. So
Okay.
your T interval. So that the 61.23 and 90.77, those are your two answers for box C. So let me go back to that other screen. Okay, so you can see where I got those numbers from. To find the margin of error is the width divided by 2. See, the width is 90.77 minus 61.23 divided by 2.
Yep.
Let me get that for you. It does not give you the width, unfortunately.
Okay.
And your teacher knows this, so they're likely to ask you questions where you can't just use the calculator for everything. You can use it for a lot of things, but not everything. And that is 14.77.
14.77.
All right, so we do have to stop here for today. Some of the questions